Welcome students to the lecture number 8 of Computer System Architecture. The main objective of this lecture is to understand what is combinational circuits. After that, we will learn what is half adder and what is full adder. Students, in the previous lectures we have learned the basic concepts of digital electronics, where we have learned that the logic gates are the basic building blocks of the digital circuits. And we have learned that the logic gates can take one or more inputs and they give one output. Okay, students, in the electronic circuits we combine or arrange the logic gates in specific way so that we can get a desired output. A few examples of the digital circuits are visible on your screen. Students, we can broadly divide the digital electronic circuits into two categories. One is combinational circuits and one is sequential circuits. Students, now let's first understand what are combinational circuits. The combinational circuits are those circuits in which the output depend only upon the present value of the inputs. It means that for a specific input combination, we have a specific output combination. It means that if we know the value of the inputs, we can predict the value of the output. A combinational circuit can have any number of inputs and it can have any number of outputs. Students, the block diagram of combinational circuits is visible on your screen. You can see that this combinational circuit is receiving the n inputs and it is giving m outputs in the result. Students, there are many combinational circuits in the computer. A few examples of the combinational logic circuits that are used in the computer are half adder, full adder, multiplexers, demultiplexers, encoders, decoders, etc. Students, before starting our discussion on half adder and full adder, let's first understand how a circuit is designed. Students, to design a circuit, we follow a sequence of steps. In the first step, we firstly identify that what the circuit is going to do. What will be the function of this circuit? Okay, and after finalizing the requirement of the circuit or the role of the circuit, we identify the input and output variables, and after that we assign names to these variables. Okay, and in step number 3 we prepare a truth table for that circuit, and in which we write down the output values for a particular set of combinations of inputs. Okay, and after that from the truth table we obtain the boolean function or the boolean expression, and in the last step we simplify the boolean expression and we design the logical diagram of the circuit. Students, now let's understand what is half adder. Half adder is a combinational circuit that performs the addition of two numbers. Students, we have learned how we can add two numbers in computer. We have already learned that binary 0 plus 0 is equal to 0, and binary 0 plus 1 is equal to 1, and binary 1 plus 0 is equal to 1, and binary 1 plus 1 is 0 and 1 carry. Okay, now we will going to represent this logic with the help of circuit, and this circuit is known as the half adder. Okay, students, so firstly we will prepare the truth table for the input combinations and the output combinations, and from the truth table you can see that if the inputs are 0 0, then the result is 0, the value of carry is 0. Similarly, you can check the other values of the truth table. Students, from the values of the input and output combinations given in the truth table, we can find the boolean expression for the outputs. For example, in this case the boolean expression for result is x y bar plus x bar y, and for the carry the expression is x y. Students, we can write the expression for the result x y bar or x bar y as the x exclusive or y. Okay, and for the carry it will remain as such. Students, now the boolean expressions for the output sum and carry is ready. Now the next step is to draw the circuit diagram, and From the Boolean expressions, we can clearly observe that for the implementation of sum, we will need an exclusive OR gate, and for the implementation of carry, we will need an AND gate. So firstly, we will draw the exclusive OR gate, and we will provide inputs x and y to it, and the output of the exclusive OR will be represented as the sum. After that, we will provide the same inputs x and y to the AND gate, which is representing the carry, and the output of this AND gate will be the carry, the value of the carry. Students, we can also draw the block diagram of half adder. The block diagram of half adder is visible on your screen. In this case, we will mark the inputs as x and y, and we will mark the outputs as sum and carry. Students, the half adder circuit was not capable to find the sum of the previous carry and the input combinations. For example, it was not capable to find the sum of the inputs 1 1 and the previous carry 1. Okay, now to find the sum of the previous carry along with the inputs, we need another circuit, and that circuit is known as full adder. Students, full adder is the combination circuit that performs the addition of three numbers, out of which two are the input values and one is the carry input from the previous step. Okay, so the full adder will receive three input values, and it will give two output values, which is the sum or the result. Students, let's now make the truth table of full adder. As we know that full adder has three inputs and it give two outputs, so we'll have 5 columns in the table, and the value of the inputs are represented as the x, y, and c in, and the values of the output is represented as sum and c out. C out represent the carry output. Okay, uh, so if the value of the input is 0 0 and the value of the carry input is 0, then the sum will be 0 and the carry out will be 0. If the value of the input x is 1 and the value of the input y is 0 and the carry input is 0, then the sum will be 0 and the carry output will be 0. Similarly, when the value of the input x is 0 and the value of the input y is 1 and the value of the carry in is 0, then the sum will be 1 and the carry output will be 0. Similarly, if the value of the input x is 1 and the value of the input y is 1 and the value of the carry input is 1, then in that case the value of sum is 1 and the value of the carry output is 1. Students, from the truth table we will derive the Boolean expression for the outputs. For sum, the Boolean expression is visible on your screen, and for the C out or the carry out, the Boolean expression is visible on your screen. Students, now the next step is to simplify these Boolean expressions, and for that we can use Boolean algebra identities or we can use K-map. So after simplification, the Boolean expression for sum will be C in exclusive or x exclusive or y. For C out, it is xy or C in exclusive or xy. Students, now the next step is to draw the circuit diagram of full adder. Students, for this we will need 5 gates, 2 of which are exclusive OR gates and 2 of them are the AND gates and one is the OR gate. Students, from the Boolean expression of sum, it is clear that it is the exclusive OR of C in and the exclusive OR of x and y. So firstly we will find the exclusive OR of x and y. It is done with the help of first exclusive OR gate. Students, the result of this gate or the output of this gate is sent as the input to the second exclusive OR gate, and the second input to the second exclusive OR gate is C in, and the result of this second exclusive OR gate is sum. Okay, students, now the Boolean expression for C out is C in and the exclusive OR of x and y, or the AND operation on the x and y. Students, so firstly we will implement the exclusive OR operation on x and y, and because we have already implemented this operation through the exclusive OR gate 1, so we will use the output of this gate and we will give this output to the AND gate number 3, The second input to the AND gate 3 will be C in. So the output of the gate number 3 will be C in and the exclusive OR of the X and Y. Students now will find the value of X, Y. For this we will need another AND gate, and we are taken this as the AND gate number 4. Now the value of the input for AND gate number 4 will be X and Y. So the output of this will be XY. Students, now the outputs of the AND gate number 3 and AND gate number 4 will be sent to the OR gate number 5. The output of the OR gate number 5 will be equivalent to the Boolean expression for Cout. Students, now let's draw the block diagram of full adder. In this case, we will represent the inputs and outputs for the full adder. The inputs for the full adder are X, Y, and Cin, and the outputs for the full adder are sum and Cout. Students, this is the end of today's lecture. I think you have understood the objectives of today's lecture, which were what are combinational circuits, what is half adder, and what is full adder. Thank you for attending this lecture. See you in the next lecture.